Welcome to Lectromec's latest video on EWIS evaluation. In this video, we will go over high voltage testing of aerospace connectors. High voltage testing is a common practice in the aerospace industry. Harnesses are typically tested at multiple stages, typically during the fabrication of the equipment, during installation, and as part of routine maintenance and troubleshooting of harnesses. The goal being to evaluate any sort of damage that might have occurred during fabrication or typical operational conditions. This equipment typically looks for breaches in the wire insulation, paths to ground, shorts, or opens in the conductors. While it is important to identify the breaches in the insulation and these other defects, it's equally important to ensure that the assessment does not damage the connectors, the important connections to the rest of the aircraft. Here, in this video, we'll show some of the consequences of using an uncontrolled high voltage test on these connectors. In the demonstration video that we'll show here in just a couple moments, we use an MS24264 connector with a 10-5 pin arrangement. This is a 5-pin connector, but in our demonstration we only use 2 pins, 1 and 2, one connected to the high voltage side, one connected to ground. This slide shows the configuration of the test circuit. Fairly straightforward, with a variable high voltage power supply from 0 to 5000 volts AC connected to the connector that was described in the previous slide, and the system was monitored with a voltmeter. Again, a very straightforward assessment. The test procedure was to connect the connector to the test circuit and then turn on the test voltage, starting at 0 volts and slowly ramping up the voltage until a sustained arc was created. Once the sustained arc was created, we hold the voltage at that level for 30 seconds and then slowly decrease the test voltage until arcing has extinguished. Now, of course, after that's done, evaluate the damage to the connector. Here is the video of the test. Here is our 5-pin connector with 2 of the pins actually connected. At this point in the video, we're at 2800 volts, and there was our first pop of the actual arc initiating. We continue to ramp up the voltage, and at 3000 volts we see another arc between the pins. Once we achieve 3300 volts, we see a sustained arc between the pins, and we keep the voltage at this level for the next 30 seconds. As you see here, the arcing continues unabated, and at this point you start to see that there's a little bit of a flare-up. This is where the insulation, the insert, and the connector starts to be damaged. Now we adjust the camera here, and we're starting to ramp down the voltage. At this point we're slowly lowering it down, and you can see and hear the buzzing stop. And the arcing actually halts at 2200 volts AC. With only 30 seconds of uncontrolled high voltage exposure, the damage to the connector is clearly identifiable, particularly the insert. When we pulled out the pins, there was no physical damage to the pins, but there was charring of the pins. Now, this charring can still act as a contaminant and reduce circuit performance. This is an important consideration when using a high voltage tester, a Megger, or some sort of similar equipment that you're looking for breaks in the wire system. Protecting the connector is also important and should be considered when determining what voltage and current levels and what power levels should be permitted on your platform. Thank you for watching this video today. If you're looking for testing or have any questions about this video, please contact Lectromec. Thank you.